Okay guys, so in this video we are going to learn how to fail. So let's get into it. So this video is going to pretty much cover the different ways of handling errors and why there is no one fit every scenario solution to this problem, and a little bit on how to reason about error handling, because that's the key thing I want you to take away from this when we're all done. I want you to think about error handling in a different way from what you may have been thinking about it from at this moment. So first and foremost, this I need to define what this isn't, and what I'm not trying to showcase all the possible ways that you can deal with errors here, guys. There are so many different strategies, and I'm just, as I was saying, trying to get you into the right headspace around error handling and the things that you should think about, and some strategies for how to, just to give you some tools around it. So it's not a guide, as I was stating here. This is not a guide for how to do error handling. It's just a showcase of some common strategies and some considerations to have with you when you are taking these decisions about errors. So the root question here was basically this. Related to this, could you do an episode on proper error handling? I would really appreciate it. I read a lot about this right now, and there are many different opinions from senior people. Some say throw errors, some say never throw, some say that you should use an either monad, some say that you should always return an undefined or a null, and it depends on the context, etc., etc. And this person is absolutely right. There are so many different ideas on how to do proper error handling. And I am going to just give you full disclosure immediately, and I will say that I fall into the bucket of that it depends. And that's the point I'm going to try to make to you today, why there is no such thing as saying that, oh, you should always throw, or you should always return a null value or something like that, at least from my perspective. So first and foremost, the main two ways just in general that people handle errors is going to fall into one of two things. You're either going to crash your program, or you're going to try to recover. Now the difference is very simple. Like if you're trying to crash, that is probably the easiest thing that you can possibly do. All you have to do is throw an error, and then that will halt the execution of the program. Done deal. And then you have the recover strategy, where you might be doing something like logging out the error and then trying to continue processing even though something went wrong. Now, which one is the right solution here? Well, it depends. It very much depends on what the impact is going to be. The root question that you should have with you when you try to figure out if you should crash or if you should try to recover is, what will the impact be if I continue? So if you're dealing with some type of very critical piece of code, let's say for the sake of argument that you are trying to place an order that's going to go out to some vendor somewhere that is delivering products to your customer. Now, if you for any reason lack the information to do this, well, then you can't really process the order. So what are you going to do? Are you going to communicate back to the person who's trying to place the order that everything is fine? Well, that's kind of misleading, because then the customer is going to get an okay back and think that, oh, I placed my order, when in reality you actually just silently failed and there's going to be no order, and now you're going to have an angry customer. But if you flip that and you think, okay, let's say that you have a batch job, let's say that you have some processing where you're doing a lot of different work, or you're sending out emails or something like that. Well, imagine if one email, there's a hiccup on the network or something. If you crash, then all the remaining emails that may have just gone through as normal, well, they're not going to be sent. You're going to have to, it's going to halt the batch job. So in that scenario, it might not be such a good idea to crash. So let's talk about the normal ways that we do these sorts of things. So usually what happens is that most people are going to do one of two things. They're either, as I was saying, they're going to crash or they're going to recover. And when you crash, you throw an error. When you recover, you have a few more complicated strategies. We're going to look at a few of those strategies. But the normal thing is that you still want to communicate that something went wrong. It is very rare that you don't want that. What we call trying to just hide that an error occurred, which you may have seen in some cases. The usual way that you see this is through that there's a try catch somewhere and there's an empty catch clause. What that person, that coder, basically has done there is to do what we call swallow the error. And swallow the error is it's a really bad thing, because it basically means that if something goes wrong, there is no way for you to know that something went wrong, because you're not throwing the error and crashing, and you're not trying to recover by just communicating that something went wrong and then continuing the execution. And that is what the log is there to do. It is the most common recovery strategy. I hope that's super clear to you. The most common recovery strategy for people doing programming is to catch the error, log out that the error occurred, and then just continuing with the execution of the program. So let's now look at some code. So the first thing that we need to take a standpoint on is local error handling versus global error handling. And we're going to look at the examples that I made for this exact thing. So let's talk about local error handling first and foremost. Now, local error handling basically means that you are at a point in the execution of a program going to try to deal with the error if the error occurs, and then you're going to deal with it in that exact location and either crash the system or try to recover. So let's just look at an example. I have this application here with a bunch of different endpoints, because this question is really, really, really broad. So I had to really rack my brain to think out a few scenarios of where these different strategies make sense. Because sometimes, guys, I'm going to be honest with you, sometimes you have the same strategy throughout the entire system, because some of the more elaborate scenarios are not actually applicable to your system. So let's look at this thing here. So this is a batch endpoint, and this batch endpoint, what it's going to do is that it's going to take in an array of emails, and I'm just faking the data right now, and then we are going to send out a bunch of order emails, and then it's just going to return here, and it's going to say that, hey, I started this batch job, I'm going to let you know when it's finished, or something like that, right? So let's look at how the batch service is structured. So the batch service is just going to take in the email service, and it's going to push it into itself here. And then it has this function here, send order emails. And as you can see, the logic here is super easy. So we're going to loop over all of the emails, and then we're going to send out each email. And if there is an error, we're just going to console log errors, and that's it pretty much. So what's happening here is that I have a recovery strategy. And as I was saying earlier, the reason why I want a recovery strategy here is simply because I don't want this to break. It's a batch job. All I really need to know is if something went wrong. So let's say that there was one specific email that didn't go out as I wanted to, well, then I can always rerun the job, and then hopefully the email is going to be sent out correctly in that scenario. And if it's not sent out successfully, maybe there's something wrong with this email and I should investigate. But all the other emails, because imagine this array of emails, it could be thousands of emails. I don't want all the other users who are just perfectly fine to not get their emails right. It's important that this is executed correctly. Now, the problem with with dealing with errors in a local fashion like this is that you might be doing double work. Now, what does that mean? Well, it basically means that when you have a very complicated system with many layers of logic, you might have the same strategy in many places. It might be the case that you are doing error handling in other places of the code, and that can become really confusing. I'm going to show you a very simple example here. So let's go into this email service. So here's my email service, and this is an email, and it's going to take a bunch of emails, and here it's just going to return a promise where it's going to check if the email address is greater than 1, and then it's going to log out an error saying that this email is not valid, and then it's just going to return an empty resolve, and otherwise we're just pretending right now. It would send out the email, and then it's just going to return the promise. Now, what's the problem with this? Well, the problem with this is that if this breaks, if something goes wrong, this is going to log out an error, but this code will never run. This try catch is completely pointless, because there's no way for this. This is designed to do its own local error handling internally. So just think about what just happened. So I have, as the caller, no idea of that this function is actually doing its own local error handling. So as I was saying, I might be doing double work, and this is pretty much double work. I am dealing with an error that will never happen at this level, because it's already being dealt with at this level. And this can become really confusing. I've seen this many times before, where people have logged out the same error in many cases, where they log and then they rethrow the error, as we call it. Basically, you catch the error, you log out the error, and then you throw it again. And that means that now you created a log, but you also put it on the caller to catch that error and deal with it as well. So in general terms, it's a very good idea to have some type of rule for how you do this. Like, you can, if you're gonna do local error handling, try to keep it at the highest level in the chain, if that's possible at all, unless the errors are different. I mean, if this is an identical scenario, so this is why I'm showcasing this, but it could have been a different type of error that I wanted to log out here and then just rethrow it. So this is a tricky topic. There's no right answer here. You have to just have a strategy for how you're going to make sure that if you're dealing with error at one level, you're not duplicating that work in another level. You could do something like this. You can do, and this is the recommended pattern for, at least for JavaScript, which you've probably heard this before. Ideally, when you return a promise, you shouldn't have a catch statement or something like that internalized. You should always just return the promise to the caller so that they can do their own error handling. And this is pretty much the same idea, where I actually do reject with an error instead. And if I call with this function, I'm actually going to, this code is actually going to execute as I expect. So I hope that makes sense to you. I hope it makes sense to you that local error handling is just that you're dealing with the error at the point of error, where the error starts, and then you just have to remember how am I going to make sure that people who are consuming this code are aware of that I'm dealing with the error at that level. So one pattern that I really like is to have the global error handling system, and this is, well, it's pretty much the opposite of doing local. You basically allow the error to bubble up to the surface, as we call it. And that basically just means that you're going to throw the error and you're going to catch it at the latest possible stage. Now let's look at an example of how that looks. So here I have a user's endpoint, and here I'm going to get a user. And this is going to deal with global error handling. So if we go into the user service, like so, I have a bunch of users here, and I'm just going to go through and try to find them. And if I don't find the user, I'm just going to throw an error. So it's called user not found error. And the same thing goes for here. Get all users is very similar sort of thing. It's just going to throw an error. This is classic. This is like the easiest thing that you can possibly do. And I would argue, if I'm going to be a little bit opinionated on this, this is how you should default. This is by far and wide the easiest thing. Now, the problem with this is that some scenarios, this is not feasible, because you might have a system that has to be available at all times, or you might have a scenario where if you're just throwing things without dealing with it in an efficient manner, you might not be catching the error. You may not be dealing with it in some fashion, and then you might crash the system, which is a really bad thing, right? But, or depends on your viewpoint, of course. But I hope you can kind of grasp this. In the local scenario, when we're doing local error handling, we are dealing with the error at the point of where it occurs, which makes it very unlikely that we're going to, by mistake, miss the thrown error. But in this scenario, we are just throwing it. We don't know if there's somebody who's going to deal with this error. So we have to have a global error handling strategy. Now, what does that look like? Well, in Express, it's fairly straightforward. This is a global error handler. So a global error handler is just a catch statement, or somewhere within the code where whatever happens, this is going to be the final point. This is going to be the final stopping point for the error when it's being thrown. It might be the case that we have a double strategy here. I could do local and global. I could have some error handler inside of this method here. that deals with the error, but I also have this option here where so that if someone's not dealing with the error, I can deal with it at the global level. I personally, if I'm going to be a little bit opinionated, I think that this is a very nice strategy to default to. I think that you should go for this by just to have this off the bat, because it allows you one central point of where you can find all the different error handling logic that you want to deal with. Now, we're going to touch on something that is very close and dear to my heart, which is error subtyping. That's very closely tied into this exact topic with global error handling. So what is error subtyping? Well, error subtyping is basically the idea that you want to be consistent with your errors. In a very normal scenario for most JavaScript developers is that they do something like, let's see if I can find an error that, yeah, like this. This is classic. So you just go and you say throw new error, and then you just give it a string. So what's the problem with that? Well, the problem with that is that this makes it very hard to do specific error handling. What if I wanted to do something special with this error, such as what I'm doing here? If we look at my global error handler here, if I'm throwing an error, let's say that I'm throwing a not found error. Well, the status code for a not found is by common practice 404. But how will I know if the error is a not found error? Well, I could, of course, just declare a not found error, a handler that just deals with that specific error, or I could like string match or something like that. But that's very tricky for me. There's, in my opinion, a much simpler solution, and that is to use error types or error subtyping. And that basic idea is just that you create a subtype of the error that you're dealing with, and this allows you to make much more powerful and custom error handling, because remember, sometimes my error case is very simple. I might just want to return the error that was thrown, and maybe with some special status code, or if there is no status, then just return a 500 for just a generic internal server error, right? But in some cases, I might know that, oh, this error here, let's say that it was this case of the batch job or something. Well, then I don't really want to return an error, because in that scenario, I might want to send an email to someone and say, hey, you know what, this error was thrown, and it was on this email, and you should probably go and check it out. This allows me a lot of flexibility into how I want to structure my error handling logic, and it's very easily accessible for me because I know that there's one single place where all my errors are going to end up, and if I just type them, I can figure out which error it is and deal with it accordingly. So let's look at a few subtypes. Let's take my status error. This is one of my favorite errors that I create when I work in Node.js, and basically all it is that I extend the error type and I add a status. And then I have it add an optional type if I actually need the type itself. So with this extension now, I can create much more powerful errors than I could if I just throw an error. And this also helps a lot with consistency. If you're dealing with a third-party integration, as an example, it's very important for you to be consistent with your errors, because as you can imagine, if you have one developer who just throws a generic not found error that's just then, and that doesn't actually register anywhere, it's going to end up here and it's going to return a 500. But what if the third party has created logic that is going to depend on that the not found error is semantically correct and returns a 404? Because they might have logic that checks, oh, this is a 500 error, oh, this is a really serious error. And they might have a different set of logic that goes, oh, this is a 404. Well, that's not so serious, or maybe it is. It's the same thing. You will see this all over. There are many, many applications where there's an error and they return a 200, which is just okay. And that's really, really bad. And you can avoid this sort of problem by creating creating subtypes from your errors, because then you're not giving people the freedom to just throw any type of error and just arbitrarily say, oh, this is a not found error in a string. They're actually going to use specific errors that are always the same, and this keeps things very consistent. So here, my status error has another subtype, and that is my not found error. So here, when I don't find something, all I have to care about is that I use this string here, and I just have to throw this, and the internals of this, it's already setting the right 404 status code because of my status error here, and then I can give it any message, which is so nice. Like an example, as we were seeing here, if the user isn't found, well, all I have to do is that I have to just give it the ID, and then it's just going to take care of it. It's just going to set the right status for me. I don't have to write that code or like duplicate. I don't have to repeat myself, which is exactly what I want. Here I'm not doing it, which is a really bad thing, because this is pretty much the same thing. Like, you could argue that this is also a 404. Well, technically not, but I hope that you get what I'm saying. So let's look at a few other types. So let's have a look at the unauthorized error. Similar sort of thing here, right? I'm just adding another layer on top of the status error, giving it the right status code, and then I'm just taking whatever message I'm getting into the, well, I can see here that I forgot to rename this. Oh, okay, it shouldn't be unauthorized. It's the wrong name. Let's do this. There, something like that, right? So I hope this makes sense to you. I'm just subtyping it even further, and now I can even take it down one further, and I can say user not found error. And the user not found error is a subtype of the not found error. Or in this case, I'm just taking an ID, and I'm actually hard coding the message that I'm going to send to the client. Now this is perfect, as I was saying earlier, when you're dealing with a third party, where they want to be, you want to be consistent. Whenever there's a user that couldn't be found, you want it to be the same message, you want it to be the same shape of error, and you just want everything to be super consistent. And this is achieved by just using a subtype. And something that I think is very cool as a sidetrack is that you can do fairly sophisticated things. Now, this is a trick that I've used a few times, and I have a few coworkers have used as well, where let's say that you have an error, and it's a classic one. Someone calls into your call center, or they call up your office and say, hey, we had an error here on our side. You need to look into it. And then the fun job of trying to sift through all the logs in the system and try to figure out, okay, which error is yours? Like, what did you do that caused this? When did it happen? And when you're using something like error subtyping like this, you can actually embed that into the message. You probably have seen that on your computer at some point, where you have an error and there's an error code of some sort. And this is exactly what I'm demonstrating here. So this token error is just a type that you can extend from and create more specific errors. And it's going to generate a random token that is going to be sent to the client. So when the client gets the error, they're going to get this random token that was created, and then since you log out this error, hopefully, you're going to be able to very easily search for where this happened and get the exact line when something failed. It becomes a very searchable thing for you without a lot of overhead to your process. So this is error subtyping. Now, you shouldn't go crazy with this, because you can make a lot of ugliness if you get too crazy, but this is I think this is fine. This is a good level to keep it at. You have a type of error. You have some way of figuring out, okay, this is this type of error, then I can do something special with that. Otherwise, I'm just going to default to error, log out the error. And then if you're dealing with statuses, as in this scenario, you can simply check if there is a status, otherwise go to 500. This is, I think, a very good practice if you're dealing with global error handling. So let's move on to our final section, where we're going to talk about errors versus return values, or throwing versus error return values. Now, this is also something that this question was touching on, and this is something that is very debated in many circles on the internet. And basically the question is, if something goes wrong, should you throw an error and crash the system, or should you return a value that represents that something went wrong? Well, there are people who are very, very opinionated about this. Some people will say that if you return an error value, you're basically swallowing an error. You're just hiding the error. And some people say, well, if you're throwing an error, you might crash the whole system instead of having a recovery strategy. Now, if you're dealing with functional programming, and as this question was referring to, the either monad, the common thing to do here is that's the power of an either monad. I'm not going to dive into that, because usually it's very rare that somebody's going to use an either monad in a normal code base. That is a very functional concept, and we can touch on that in a separate video. But the basic idea, the basic philosophy of 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 functional programming is that you should not create impurities, and throwing an error is an impurity. So that's why we create the either monad, which allows you to return an error value, but it also makes sure that you short circuit all of the things, all the processing and all the risk that comes with trying to have a recovery strategy to a point where this doesn't actually happen. It's just going to skip all the logic that depends on that either monad. And that is a very powerful thing. But in a normal scenario, what you really need to think about when you're not dealing with either monad and functional programming is what, as I was saying, what will happen if something goes wrong here? Like, what is the impact of crashing versus returning a value and then maybe continuing execution in this scenario? And I will argue that it always depends. Sometimes you want to continue, and sometimes you want to return an error value, and sometimes you want to actually halt execution. So let's look at that. I have an order service here. I think I even have an entry point here. Yes. So here we're just going to create a user, and we're going to create an order. And let's have a look at this. So here is an order, and here's a constructor or like a function to create the order, and here's an empty list of orders that I'm just using for demo purposes. And let's have a look at this. So here's two versions of the same function. Now, in one scenario, the first scenario, we're going to throw an error. And in the other scenario, we're going to return null. Now, what I argue is that the times that you want to return a error value, such as null, or if you're using JavaScript, you know that index of on an array returns -1 if it doesn't find the element. And I think that's a really nice thing, because when you're using index of, basically the only thing that can happen with index of that might be wrong is that you don't find your value, and you simply represent that with a -1. And that is a very nice, I think that's a very nice strategy. If there's only ever one thing that can go wrong, returning an error value that represents that something went wrong is a very nice way of communicating that one thing actually did go wrong. In this scenario, however, I think that we're doing it incorrectly. Can you spot the problem? Well, the problem here, if you ask me, is that here there is more than one thing that can go wrong. If we look at this function here, so if something's wrong with the name, we're going to throw an error that communicates to the caller that something was wrong with the username. But if something's wrong with the address, then we're going to communicate that, oh, there was something wrong with the address. But here, there's no way for us to know what went wrong. There's no error, there's no log, there's no nothing. So how will I know as the caller what's wrong? It's impossible for me to know, because it's the same value for both scenarios. So this is an example where returning a null value is a really bad idea, because there's too little information. So when I'm debugging this, I need to go and step through this code basically, or add my own logs to figure out which thing went wrong. And here it's super clear for me. In a production environment, this is definitely what you want to be doing, because this communicates directly, oh, something went wrong on this line in the code, and it was this thing that caused it. So let's move on further, because if you see this code here, you might think, well, obviously, Frederick, it's the best thing is to always throw an error, because that's very you communicate things, right? Well, yes and no. As I was saying, there is one other scenario where I think that it's actually better to return an error value that represents that something went wrong. Let's have a look at these two functions. So we have one function that's called maybe find order, and what that's going to do is that it's going to return an order or undefined. That's basically what it's going to do. And then we have a find order, which is going to go and find an order, and it's going to throw an error if it doesn't find the order. Now, some of you will say that, well, obviously, Frederick, the best thing here is to just use the find order function, because if you're trying to find an order and you return an optional, well, then the caller is always going to have to check if the order is there or if it isn't there, and maybe it's going to throw then you're going to have to throw an error, because if you can't find the order, well, of course, then you're going to have to throw an error because you can't continue the execution of the program. And this is where I go yes and no. Yes and no. And the reason why I'm stating that it says yes and a no here is because I don't know what the caller wants. Think about that. what I'm trying to say here is that if you assume that you're always going to want to deal with the fact that you didn't find the correct order that you're looking for in this fashion, then you're making a decision on behalf of the caller. If you only have this function, then the caller is always going to have to accept the fact that if there is no order, then there's going to be an error thrown. And if that's not what they want, maybe they want to handle the error in some other fashion, well, then they're going to have to put a try-catch around this function and then just have a catch clause that deals with the continued recovery method for when they didn't find an order. So what I argue is that if you have both of these, you are communicating two different things, and you are dealing with two different types of use cases. Because maybe if I'm trying to show an order to a user who goes to my web shop and they want to see their order and I can't find that order, well, then maybe I should throw an error. Because I don't want, there is no order that they're looking for. Because I know at that point in time that there should be an order, but there isn't. So something is something is clearly wrong here, right? But what if this function is being consumed by someone who doesn't know if the order is there? Well, that's a different use case. It's a completely different scenario. Maybe I'm dealing with some testing logic, or maybe I'm running a batch job, or maybe I just am gathering up some statistics or something like that. Maybe I'm just checking. Maybe if someone's trying to update the order, well, then I don't want to throw an error if someone's going to update the order. Then I just want to see if the order exists. And this is exactly what this is doing. It's just checking if the order exists. And that's something I hope you understand. These are different perspectives on the same thing. In this scenario, it makes sense to return an error value if something goes wrong, because I don't want to consider that this is an error. There's nothing wrong with that I don't find an order, because I don't know if the order is in the system. But here it is wrong, because here I expect the order to be there and it's not. Then I should probably deal with that in some fashion. I hope that makes sense. So let's go on to the final thing that we want to talk about, and that is empty return values versus null. Now this is very, I'm just going to cover this because you may never see this in actual production code, but I want to touch on it anyway because it's something that has been popularized in some best practices books in languages such as Java. So I feel like I am obliged to at least touch on it. So what is an empty return value? Well, as we were saying there, in the case where you're returning a error value, which is usually null or undefined or something like that, or -1 if you're using index off, well, there's another strategy to this, and that is where you have people who argue that, all right, but maybe I don't want to deal with the fact that something went wrong. Maybe I just want my program to behave as if nothing ever went wrong. This is very similar to how the either monad works, because the either monad takes two different functions, one for errors and one for the actual success of the thing. And when you're consuming an either monad, what's very powerful about it is that when you're coding, you don't actually know if you're getting the value or if you're getting the error case. And if something goes wrong, it's just going to skip all of the logic that you have written for the success case and go straight to the error case, which is a very powerful thing. This is a similar approach, but it's not, I'm saying this is much more risky in many cases, but we're just going to kind of touch on it anyway. So what if you're in a situation where you don't want to return null? Maybe you want to return something that represents that this value, well, there's nothing wrong, something has gone wrong, but there's no problem with the fact that something went wrong. So some will argue that you want to just return a value that represents an empty representation of the thing that you're dealing with. And this is very useful for, as I was saying, if it's really important for you to just never crash, ever, like everything should always pretty much just work, or if you don't care that something went wrong, you just want the value so that you can continue processing. Now this is a niche case, I will admit, and there is a lot of dangers with this. So some people say that this is an anti-pattern, and I have to admit that I think in many scenarios it is true. This is a bit of an anti-pattern, but I'm going to show you a slightly contrived example of how this works so that you can spot this pattern if you see it. So let's have a look at the order service. Let's talk about a bad scenario for using empty values. So here I'm creating an order. Now notice that if the product ID isn't up to scratch, I'm going to return an empty order. So basically what I'm doing here is that I'm creating an order with the no ID set as the ID, and otherwise I'm just going to return a completed order. This is really bad. This is really bad. If you see something like this, this is like, you should really look into it. Because here, I'm basically in a situation where the person who was trying to create the order, they don't know that the order didn't succeed at all. And the worst part is that I'm creating a ID that is going to be duplicated. This ID is going to be the same every time something goes wrong with the product ID. And that's really not something that I want. If we have a look at, say here, this is it's a scenario where you really want to return an error value. Like if you're going to do anything here, like you should not return an empty value here, because the impact of doing the impact of this going wrong is so bad that it will affect the entire system really, really negatively. The database might throw an error saying that, oh, you have two IDs of the same type or something like that, right? So here we kind of failed that question that I was talking about earlier. We have not really asked what is the impact of trying to catch this error. Here we should throw an error, or at the very least return a null value of some sort, because the impact of continuing the execution of this program is really, really dangerous. So something like this is slightly better. Now the issue with this is of course still that, well, in this scenario we kind of lost the benefit of just returning the same type all the time, because now we're returning an order or null. In this scenario, the benefit is that you're always dealing with an order on the other side. So if you don't care about the fact that something went wrong, you can always make your caller code much cleaner and nicer, because it doesn't have to deal with the possibility that something went wrong. This is also true for when you're throwing an error, because remember, if something can go wrong, you're always going to have to deal with it on the caller side, which is going to be more work than if something can never go wrong. So let's look at the case, slightly, I will admit, contrived case of when it could be sort of useful to have an empty value, or to just use an empty value. So here I have a product service, and I have two methods here, which is called create draft product and publish product. So create draft product, the intention behind this is that, let's say that we have a system where people can upload their products that they're going to sell on our web shop, right? Well, when they're designing their products, that they might be inputting a bunch of different information. Well, it might be the case that we don't want them to be forced to submit all the information at the same time. And you might want just to have them, to allow them a draft type of work style where, all right, so I input some of the information and then I can just save my draft, or we autosave the draft in case something happens. Let's say that the network goes down or something like that. Then we just autosave the state of the draft that you're creating, and then you can continue that draft when you're good and ready. And this is kind of where that's sort of where this idea comes from, where, all right, so you can create a optional type for the information that you have on your type, and then you simply polyfill in the default values if they are missing. So here we're creating a so-called empty object, or an empty value. It just represents the type of object that you want to create, but with default values. That's, if that makes sense. I could have made all of this optional, but I don't want to, because when I'm actually going to publish this product and I'm going to persist this product in a more permanent fashion, I want to always be sure that this information is there. This is required information for my feature, but I don't want it to be required in the state where in the case when the user is just creating the draft, if that makes sense. So when I do something like that, I can do something like this. So when I want to publish my product, well, then I'm just going to go and find my product, and then I'm going to check, is the name valid and is the price valid, and then I'm going to return that product. And well, I can just return it here, but you can just imagine that I would publish it, or I would just flip a switch or something, and now it's going to be public, right? And otherwise I'm going to throw an error. But this is also an optional thing. Maybe I don't care if we're publishing half finished products. Maybe it's more important for me that the system is always working. Well, then I would simply do this. I would simply not even do this check, and I would just return the product every single time, even if it is an unfinished product, because maybe I reckon that, well, this is not a problem for me, because if a user goes and sees that this product here has a bunch of weird values, they're going to report it to me, and then I can fix it, or we can just update it. And that is more important to me than that because I don't want the system to break, right? It's a priority type of thing. Now, I will just highlight and say, in many cases, I can see the argument that this is an anti-pattern as being very true. You should be very careful with this, because there is a very high likelihood that you can create some really serious bugs and issues if you're doing this in an incorrect fashion. So, to summarize, the main thing that you should take away from this is to answer this question. Whenever you're picking your strategy, what will be the impact of crashing, and what will be the impact of trying to recover when an error occurs? That is what's going to drive the answer to how you're going to solve the problem. By default, I highly recommend that you deal with just do global error handling. It's the simplest thing that you can do. Throw the error and let it bubble up to the top, and then have some type of global error handler that just knows how to deal with all the errors. This keeps things very crisp and very clean. You can use error subtyping in order to keep things very consistent and very nice. Be very careful though. Sometimes, as with batch jobs and other long-running processes, you don't want to just throw the error. You want to deal with it in a local fashion. And then finally, when it comes to returning an error value versus throwing an error, it very much depends on the perspective of the caller. Think about, if there is more than one thing that can go wrong, well, then maybe throwing an error is the way to go, because it's very easy for you to communicate what went wrong of all the possible things. And if there's only ever one thing that could go wrong that may not even be an error, such as when you're trying to find something that may not be there, well, then maybe you need to provide one way of where you throw an error because you expect the value to be there, and one way where you maybe expect the error to be there. You don't know. It depends. And empty return values, by standard, like normally, don't use these things. You just be aware of that they do exist, and there are certain situations where this might be very useful. Have a great day.